Good morning, good afternoon, good evening. Whenever you are watching this video, let me welcome you all to our channel Future Endeavors. Okay, so in the previous class, we have been discussing about the chapter machines. Okay, so we have until the next previous video, we have discussed about the concept of machine, the various functions performed by a machine, how the machine can be used as a force multiplier or as a speed multiplier, what are the different technical terms related to a machine, load, effort, mechanical advantage, velocity ratio, input work, output work, efficiency, and relation between MA, VR, that is velocity ratio, and efficiency. So we have discussed all of this. Today we will be going to discuss a special topic, that is levers. Okay, so today we will be discussing about levers. So students, what idea do you have about levers? I think you all have seen levers. You daily some of the levers you may be using in your daily life. They may be around you, but you may not be specifically knowing them. So first of all, just let me clear the concept of lever by giving some examples. Now, here the spelling of lever is L-E-V-E-R, not L-I-V-E-R. L-I-V-E-R means the lever which is a part or organ of our body. So please don't be confused with the spelling. It's L-E-V-E-R. Now, see, so when I'm going to give example about lever, first example that I can give is a scissor. Yes, you have heard right. A scissor is a very good example of a lever. You can also take the example of knife, that is also lever. So all these things that you use in your daily life can be termed as lever. So what is the basic criteria for an object to be lever, or rather you can say that lever is a kind of machine. So what are the basic criteria that you can refer a machine as a lever? So for that you have to understand the definition of a lever. So how can you define lever? We can define lever as a rigid, straight or bent bar. So lever can be defined as a rigid, straight or bent bar. So if I consider the case of a scissor, so there are two long blades, two handles. Okay, so this can be regarded as rigid straight bar, and which is pivoted at a certain point, and that particular point is called, what is this point called? This point is called the fulcrum. Okay, so this is the basic definition of lever, that it can be defined as a rigid straight bent bar pivoted at a certain point, which is regarded or referred to as fulcrum. So fulcrum is nothing but when you use a pair of scissors, you see that the two blades of the scissor has been hinged at a certain point. Haven't you noticed it? So that particular point is actually referred to as the fulcrum. So fulcrum can be regarded as a point, pivotal point in a lever about which the lever rotates. Now you see, when you use a scissor, you see that when we are using a scissor, so consider this as a scissor. So when you use a scissor, the scissor blade of the scissor moves, isn't it? Moves around, isn't it? It's moving around. So fulcrum is basically the pivotal point about which the lever can rotate or the lever can move around. Okay, so that is the basic concept of a lever. Fine. Now, so lever. So this is the basic definition of a lever. Now, also you have understood the term fulcrum, isn't it? So fulcrum, if you want to write it, you can note it down. That fulcrum is a pivotal point in a lever about which the lever rotates. That is the fulcrum. Okay, so before going into details about lever, so I think you have understood the examples that I have given: scissor, a knife, a nutcracker. Okay, all these things are actually lever. Okay, so now in case of lever, see, if I just simply draw a schematic diagram of a lever, how can a lever be represented? So rather simply you can represent a lever like this. Okay, I consider a straight bar, not a bent bar, but rather a straight bar. Okay, now somewhere in this straight bar, the lever will be pivoted. Okay, so let us consider that it has been pivoted at any point like this. Okay, so this is the pivotal point, and this point is referred to as the fulcrum. So this is the fulcrum of the lever, fulcrum. And at a certain point, actually you overcome the load. So that point can be regarded, say, this is as the load point. So this is denoted by the letter L. And at a certain point, you basically apply the effort, and that point can be regarded as the effort point. So actually, schematic diagram of a lever can be taken to like this: that there is a fulcrum, a point where the load is overcome, that is the load point, and a point where the effort is applied is called the effort point. Now compare this example with a scissor. Okay, so a scissor is something like this. So it has two blades like this. It is pivoted here, and here is one angle, here is one angle. So this is an example of a lever. Now here it is pivoted. So this is the fulcrum of the lever. So this is the fulcrum, isn't it? This is the fulcrum. You actually what do you do with a scissor? You either cut a paper, cut a cloth. So actually you cut it at this point, isn't it? At this point. So this point here the load is taken, and at the handles you apply the effort, isn't it? So this is the basic concept of lever. So I think comparing the diagram of a scissor with the schematic diagram of a lever, the concept is clear. Okay. So in a lever, basically what you have a fulcrum, a load, and effort. Along with this, see, there are also two other terms that I will be discussing. The distance of this load point from the effort, distance of this load point from this effort, distance of this load point from this fulcrum is regarded as the load arm, generally denoted by the abbreviated form LA, and the distance of the effort from the fulcrum is regarded as the effort arm. In abbreviated form it can be represented as EA. Okay, fine. So these are the technical terms that you must be acquainted with if you are reading about or studying about lever. Okay, now so this is the main terms related to lever. Now we will be quickly moving on to the principle of lever. Do you know the principle of lever? Okay, so let us quickly recap or quickly just go through the concept of principle of lever. Okay, I think all of you have seen the videos related to chapter 1, moment of force. If not, please go through that chapter. I think it will be helpful for you to understand the principle of lever. Okay, why I am saying this? Because I think you have all noted this diagram. If not, please pause the video or just move back a little and note that diagram. This is very important for your clearing of the concept. Okay, so if I consider the principle of lever, in short I can state the principle of lever as the principle of moments. Okay, in short I can state the principle of lever. So principle of lever can also be stated as the same as the principle of moments. So that is why I am saying that if you have not seen the videos related to the chapter moment, you must be going through those videos. I think the concept of principle of moment will be clear. So the principle of lever is actually based on the principle of moments. Okay, principle of moments. Okay, so those who have watched the video, I think you must have remembered what is the principle of moments. That under equilibrium condition, okay, the total anti-clockwise moment about a certain point is equal to the total clockwise moment about that same point. So this is the principle of the moments. So in case of lever, how can you apply this principle of moments? See, just think about the diagram that we have drawn in the just previous shots we have seen. So this is a rigid bar. Okay, it has been pivoted say at a certain point. Okay, it has been pivoted say a certain point. This was the point. Okay, here you apply the load and here you apply the effort. Okay, and this distance is the load arm LA, this distance is the effort arm EA. Okay, fine. Now, so principle of lever actually under equilibrium condition you can say that the moment generated by the load in this figure will be equal to the moment generated by the effort in this figure. Okay, so if I say that, so what is the moment generated by the load? Say it will be load into the distance, perpendicular distance is load arm from the fulcrum. This will be equal to the moment generated by the effort, this is the effort into effort arm. So this is the basic principle of a lever, that the moment generated by the load will be equal to the moment generated by the effort. Under equilibrium condition, these are equal. So from this I can say this implies that load by effort will be equal to effort arm by load arm. And you know that this, if load by effort, this term, I think you have remembered. If you have not watched the previous video, please go and watch the previous videos. This ratio of load to effort is regarded as mechanical advantage in case of machine. So for a lever you can write that the mechanical advantage is equal to load by effort, as well as it can be also stated as effort arm by load arm. So this is very important regarding solving the problems, because this concept will be helpful for you to solve the problems. So mechanical advantage of a lever is equal to effort arm by load arm. Okay, so I think the concepts are clear. Fine. So these are the main concepts of a lever. Under ideal condition, you can definitely understand that the equilibrium condition, so we can write it as load into load arm equals to effort into effort arm. Fine. Now, then we will be moving on to the classes or types of lever. You know that depending on the position of the load, effort and the fulcrum, there are three types or classes of lever. So let us quickly move on to the class of lever. Okay. So what are the class of lever? See. So classes of lever can be actually categorized on the basis of the position, respective positions of the load, effort and the fulcrum. Isn't it? Load, effort and the fulcrum. So first of all, so lever, its types or classes. So first is class 1 lever. First is class 1 lever. Class 1 lever. Okay, so class 1 lever is actually those kinds of lever in which the fulcrum will be in between the load and the effort. It might not be actually exactly at the middle point between the load and the effort, but it should be definitely in between the load and the effort. So class 1 lever, just I am representing this by the diagram. Class 1 lever is something like this, where this lever, the fulcrum will be in between the load and effort. Here is the effort, say here is the load. So this is the diagram, schematic representation diagram of the class 1 lever. So can you name some class 1 lever? Obviously, I have mentioned it in the beginning of the video. Scissor. A pair of scissors is an example of class 1 lever. A nose plier is also an example of class 1 lever. So wherever you see that the fulcrum is in between the load and the effort, that lever can be regarded as the class 1 lever. So for a class 1 lever, you can see that the mechanical advantage, what will be the values of mechanical advantage? So as you have seen from the principle of lever, mechanical advantage can be regarded as effort arm by load arm, isn't it? Effort arm by load arm. So see, in class 1 lever, so if I ask you the question that class 1 lever, does the class 1 lever act as a force multiplier or act as a speed multiplier? Can you answer? Yes, definitely you can answer, but you will be saying that we need to know the length of the effort arm, the load arm. Definitely, seeing from the figure, you can say that the effort arm can be either longer, shorter or equal to the load arm. So class 1 lever can act as both force multiplier as well as speed multiplier, or none of those also. So if I consider, so there are three cases of this mechanical advantage for a class 1 lever. If I consider the effort arm to be greater than the load arm, then definitely the mechanical advantage will be greater than 1. And if the mechanical advantage is greater than 1, then it is acting as a force multiplier. It is acting as a force multiplier. Okay, force multiplier. Now, can you give me an example, or can you think of an example actually which is a force multiplier? See, I think you have all seen those big scissors used for cutting the stems of the plants. In the garden, the gardeners generally use those big scissors, generally which have a long handle. The handle is long, but the blade is shorter. In that case, effort arm is longer than the load arm, mechanical advantage is greater than 1, and that kind of scissor acts as a force multiplier. on the other hand, if I say that the effort arm is less than the load arm, then definitely mechanical advantage will be less than 1. If I consider mechanical advantage less than 1, then it is actually acting as a speed multiplier. You consider a normal scissor, household scissor with which you can cut cloth or cut paper. Can you just imagine, or if you have one around you, you can just see that the handle is shorter and the blade is longer. So the load arm is longer. That kind of scissor is actually a speed multiplier. Mechanical advantage less than 1. Because see, just imagine, you just move your hand a little bit and you cut quite a long piece of cloth easily, fastly, very swiftly. So that is actually speed multiplier. And if I consider the third case, where the effort arm is neither greater or lesser but rather equal to the load arm, so this kind of lever has mechanical advantage equal to 1, and this is neither a speed multiplier nor a force multiplier. Okay, so neither a speed multiplier nor a force multiplier. So rather it will be acting as a instrument for changing the direction of the effort, application of effort. I think when you are thinking of an example of this kind of lever where mechanical advantage is equal to 1, I will not give you the example. I will rather leave it to you. Please do mention in the comment section that which kind of lever or which kind of machine that you are using can be regarded as this kind of class 1 lever where the mechanical advantage is equal to 1. Okay, so I will leave that to you. Now quickly moving on to the class 2 lever. So class 2 lever, in class 2 lever I will just changing the diagram a little bit. Class 2 lever. So what is the case of the class 2 lever? Let us see. Okay, so class 2 lever, in class 2 lever basically what you have fulcrum on one side, okay, the load comes in between and the effort goes at the other end. So basically here the load is in between the fulcrum and the effort. So this is the schematic diagram for a class 2 lever. So for a class 2 lever, always this mechanical advantage will be greater than 1. Why? Because for class 2 lever, effort arm will always be greater than the load arm, and definitely the mechanical advantage will be always greater than 1, and hence this kind of lever is always a force multiplier, isn't it? Force multiplier. So can you give an example of class 2 lever? Nutcracker. Think of nutcracker. You have all seen nutcracker. Your grandmothers generally use it to crack those nuts that are given in the beverages like pan. Okay, so you must have seen those nutcrackers. So those are force multipliers because you keep the nut in between, you apply the force at the other end like this. See, if this is the nutcracker, okay, this is the nutcracker, this red and blue pen, you apply the force at this end and you keep the nut in between and you just push it, you apply less force, you get more output. Okay, so this kind of lever is actually force multiplier. So example is nutcracker. Okay, now, and what is the other kind of lever? So the remaining kind of lever, the last kind of lever is the class 3 lever, whose schematic diagram will be something like this. I will be just making some modifications in my figure. So this is, I am talking of class 3 lever. So here the effort will come in between and the load will be at the other end. So the effort will be coming in between the fulcrum and the load. Those kind of levers are called the class 3 levers. For class 3 levers, the mechanical advantage, as you can see, effort arm is always less than load arm, always. Hence this kind of lever has mechanical advantage always less than 1. Hence they are always speed multiplier. So I think the concept is clear, that class 1 lever can act as speed multiplier or force multiplier both, and class 2 lever is always a force multiplier, whereas the class 3 lever is always a speed multiplier. Okay, so I think the concepts are clear. Fine. So with this we will be coming to the end of this class. Time is not permitting us. We will be seeing you in the next class. I will give some examples from our body which acts as class 1 lever, which acts as class 2 lever, class 3 lever. I will give it in the next class. Please study the concepts of lever. So till then, the next class, please do study well. Mention any queries in the comment section. If you have, we will be happy to solve it. And till the next class, we will be just ending our class here. Thank you. Goodbye.